Here we're going to look at interpreting standard deviation. So on the top half, it says when interpreting the standard deviation, remember that as a measure of the typical amount an entry deviates from the mean. The more the entries are spread out, the greater the standard deviation. So if we look at these three examples, this first example has a mean of 5, right? So this would be kind of right down the middle here. And the standard deviation is 0. So nothing deviates here. All 8 of our entries are at 5. So that's why your standard deviation would be 0. In the second example, our mean is still 5, but this data starts to get spread out a bit to the left and a bit to the right. Because this data is now starting to spread out, our standard deviation is going to start increasing. So it's about 1.2. And then in the third example, our mean is still at 5, but we have no data entries there. But now this is being pulled further left and further right. So in turn, our standard deviation will continue to increase. So what does this look like in practice? All right, in example 5, they're asking us to estimate standard deviation without calculating, estimate the population standard deviation of each data set. So if we were to look at example 1, all 8 of our data entries are right in this same block here. Okay, there's no variation, there's no deviation from that. So since each of the entries is 8, there is no deviation from the mean. All right, everything is at that mean of 4. So we could say here is that since there's no deviation from the mean, our standard deviation would be equal to 0 because it's not going anywhere. There's nothing moving left, there's nothing on the right. All the data entries are at the same point. In problem number 2, now we have this mean of 4, right? Our mean is right along this 4, and we have some data that is to the left and some data that's to the right. Both of those data, or those two groups of data, are at 3 and 5. So everything either is 1 less than the mean or 1 more than the mean. So what happens here is that, pen's not working. So each entry, there we go. Each entry is plus or minus 1 unit from the mean. So since everything is within 1 unit, we can say that the standard deviation is going to be 1. Everything is 1. So mean of 4, all of our data is at a 3 or 5. In the third group, or the third example, now we still have our mean of 4, but this time our data is either 1 to the left or 3 to the left, and some of it's 1 to the right, and some of it's 3 to the right. It isn't even spread. All of our groups are the same size. So what ends up happening here is that each entry is either plus or minus 1 or plus or minus 3 units from the mean. Since they're all plus or minus 1 or plus or minus 3, we can't just say everything is a standard deviation of 1 because some of it's 3, and we can't say that's 3 because some of it's 1. So we can say that the mean is going to be approximately 2. If you were to actually calculate this, you would turn out to be 2.2, and the reason for that is data further from the mean is going to have a more of an impact on the standard deviation. But the idea is that we're just trying to estimate here. So saying that it's approximately 2 is good enough for us. It's good enough for our purposes.